Okay, talking about self-locking nuts.
I would probably make Tom the professor of the class.
Okay, so we have the tall self-locking nuts, which are used for what? Tension. What if you got a shear?
Short.
Well, then you just go with the shorties. Okay, how do you know the difference between the tall and the short? One's tall, one's short. You look at the difference between the two. Once you get to know them for a while, you'll know which one is tall, which one's short. But that's the same thing. This is a 364, which is nice. 364, smaller number, smaller nut. 365, bigger number, bigger nut. Okay, that works in my life. Low profile, self-locking. Oops, can't see that because let's see. My writing is underneath the picture. Got to fix this stuff. All right. Oops. We want that one. Okay. So where did I leave off? Here, we'll do this one. Okay, so point number 2, MS 20 364 and an AN 364 or an NAS 1022 is tension load.
No.
Shear load, sorry. Just making sure somebody is paying attention. I want the hard eraser. Why can't this be there?
Technical difficulties on this side of the class.
Yeah, that's what's throwing me off over there. You guys are all in jack wagons. All right, is shear load. Shear load. All right, all of them. The 364, 365 uses a fiber or nylon insert that grabs. It's an unthreaded insert. Grabs the bolt. Grabs the bolt. So the nut grabs the bolt and prevents from turning. Is it reusable?
Yes. Possibly.
Reusable if the nut has a minimum prevailing torque or application torque and that torque is found in AC 4313 chapter 7 page 7-2 also, this has nothing to do with being reusable, so I don't know why it's here, but anyway, you must have at least one full thread showing past the nylon. What if you put it all together, torque it down, and it's flush with the nylon? So what do you got to do?
Take it off.
And what?
Use a longer bolt.
Use a longer bolt.
Or change the washer.
You could go to a light washer. Take from a thick to a thin washer. Yeah.
How would anyone know if
You
you reused it?
would know. How would they know? Oh, so
Because if you took it off, it would.
You can take it off.
That's possible.
so like if you had a couple in your hand, how could you tell which ones were being reused and which ones weren't?
No, if you put one on, that was still. It wasn't on that chart. That was up to but it wasn't up to spec.
Okay. How would anybody know?
Because you pull it
You
off.
wouldn't. You wouldn't.
Second.
Nobody would know. Yeah, it would look fine. I guess when it fell off, we'd know. But no, quite honestly. So if you take a nut off and you're like, I'm going to reuse the nut, and I really don't want to check prevailing torque. I don't want to deal with all that. I'm just going to see. It kind of doesn't really go on by my fingers. I need a wrench, or even if it screwed all the way down, and you're like with my fingers, like, just torque it. It'll look fine. You would have no idea. Does that answer the question? You're shaking your head like, yeah, that's the way it is.
Now, would you personally ever use a self-locking nut like that?
Yeah, sure. Try right there in AC 4313 tells me I can. Not for use where temps exceed how much? 250 degrees Fahrenheit. And I think I already mentioned this once, for not for use where bolt or nut are subject to rotation. All right. What if we have to go over 250 degrees? All right, so there's our prevailing torques. Here we go. So this is often called the high temp self-lock nut, but it's only good up to 450, not very high temp. So you're building an airplane, which is something I used to do a lot, like, you know, take it all the way down, put it all back together, use new hardware. Where would I make the make the distinction between maybe doing this nut or one of these nuts?
Location.
I mean, where would be a good rule of thumb? Where would I use these nuts?
The door.
The door. Okay, everything behind the firewall. Everything behind the firewall should be 250 degrees or less. Where would I use then the low temp, high temp? Everything forward of the firewall, not everything, forward of the firewall. That was kind of my rule of thumb. So I would use stuff forward of the firewall would be all this type of nut. Not that everything forward of the firewall reaches that kind of temperature, but it just made good sense to me to do that. That's the MS21045, the AN363. And along with that, should I have a small shear nut? Say no. Nope, they don't make them. So these just come in the tension, the taller that I'm aware of. They make different kind of nuts. So the way this one works is you can see that they've cut it. Like a little monkey trained to use a hacksaw, and he cuts slots in it, and then they put this part in a vise and squeeze it in. So this is actually smaller than what the bolt is. So as the bolt goes through it, it actually has to spread this part of the nut out, and that grips it really tight. Which also means that these nuts can be a little problematic getting on. They can be pretty tight. I'm going to go minimum prevailing torque. We'll call all metal. All metal. Sometimes called high temp. I got to go up a little bit, high temp. But it's not really high temp because max temp is 450. So could I use this on an exhaust?
No.
Definitely not. Although I see it done. All right, so we have the MS 21045/AN363. That we'll call that the pinched end. A pinched end to grip the bolt. Okay, then we have the MS 21046. Again, I don't need you to memorize part numbers. It's just, what else am I going to call it? Uses an out of round end. There we go. 21046. Yep. So it's actually kind of pinched in here, I should say. but it's not quite round, so one side is a little bit smaller than the other. It also uses a reduced size wrench on here. So it's funny, it's a smaller wrench size, but a bigger footprint down here.
Would you still call that like a shouldered nut?
Yeah, that's not a bad name for it. I can call it shoulder nut. Let me see. So, applicable to both nuts. Applicable to both all metal. What about them? You must have one thread showing. Full thread. What else? For use, where temps do not exceed 450 degrees Fahrenheit. Well, why?
Because it to expand and loosen?
Ooh, that's good thinking right there. It's not right, but that was good thinking. No, I'm serious. That was good. That was good. Okay. So often I'll see mechanics try and use these two nuts to hold exhausts onto cylinders where the temperature gets much higher than 450 degrees. And what happens is the CAD plating starts baking into the base metal and it becomes extremely brittle. And I mean extremely brittle, to the point where I've often tried to take them off and the nut will crumble in my socket. It comes right off. Easy off. Higher than 450 degrees. The CAD plating bakes into the base metal, and nut becomes brittle. And nut becomes brittle. It's like peanut brittle, but it's nut brittle. And not for use where subject to rotation. How far can I go up here? I'll just keep going until somebody starts crying. Okay. All right there then. Okay, so what is a true high temp nut? Since we're going to talk about that. A true high temp nut. Something I would use on exhaust. There we go. This is what Continental uses. These are Continental 222 exhaust nuts. They're actually completely made out of brass or bronze, some sort of non-ferrous metal like that. Non-ferrous? Oh, not asking me. And let me see, do I have the... Now, light combing uses corrosion resistant stuff, block washers and stuff, so that's what you get there. So high temp nut, let's see, I'll just put this where temps exceed 450 degrees. We can just leave it at that. C for castellated. Castellated nuts. Okay, an AM365 was the tall self-locking. Then the AM364 was the shorter one. And wouldn't it be nice if castellated nuts did the same thing? But no, the taller one is an AM310, and the shorter one is the AM320, backwards. So if you look at that 320, there are not a lot of threads in there. There's about 1.5 down here. These things strip out super easy. So you have to use the low end torque, or you'll find out why. What's next? Oh, I remember that one. Okay, so when you use these, there are two ways to install, well, there's many ways to install a cotter pin. There's only two right ways. Tim sent me a great picture today. It looked like they basically tied it in a knot on this side. Well, that's wonderful too. This is the preferred way where it comes through, and you bring it over the top of the stud and then it's cut. So don't let it come over and down and around over here. And the other one is bent down around a flat of the nut. That is the proper way. The alternate way is to rotate this 90 degrees and bend each side around that way. It is acceptable. All right, castellated nuts. What do I do? All right. Nuts used with drilled shank bolts. Bolts. Nut is secured with cotter pin. Sometimes safety wire. All right, so if I have a item that I'm bolting something to, so there's one item, and here's the other item I'm bolting to the top of that one. And so this has threads. What kind of hole is that now? Blind hole, okay. And so I decide, well, the manufacturer decides they're going to put a stud in here. So here's my stud. Comes out. Got the threads on it. But they've drilled a hole. What goes here? Okay. So first I'm going to add a washer. Then I'm going to put my castellated nut on. Oops, good luck here. Castellated nut. Good enough. There's my castellated nut. And I put a, what here? Cotter pin? Yeah. Put a cotter pin, and it comes in, it folds around one way or another. Folds around. Bad drawing, whatever. All right, am I good? Got a castellated nut, got a cotter pin.
What's going to stop the shank from coming out?
Right. So I take a wrench, and I put it on this nut, and I back it out. What do I end up pulling out? So now what do I have? Basically just a bolt that was never safety to begin with. Everybody follow?
Yeah.
You cannot use a cotter pin in this situation because the entire thing just comes out. And so what you end up with is a stud. In your hand, you'd be looking, well, there's a stud and a washer and a castellated nut, and there's my cotter pin. Now, the nice thing is you don't have to change cotter pin when you want to change stuff. You just put it right back in, right? Okay, so this does not work. You cannot put a cotter pin here. You must use safety wire. So that holds the stud in. So. Or cross-thread it. Let's see. So if nut goes on a stud, this is called a stud here, not a bolt, a stud, safety wire must be used. Safety wire must be used. Otherwise, you just made a bolt, is all you made, with a removable head. Where would I use a castellated nut versus a self-locking? There you go. So I'm going to use it on parts subject to rotation, such as, not the wheel halves, but the actual wheel holding onto the axle has one big nut, and it's always castellated and has a cotter pin going through there. If I have a conrod, no, conrod's not subject to. They are, but not a bad example. It's not really subject to rotation, because connecting rods have cotter pins, but all new engines don't. They found that was just a disaster. So clevis bolts used in shear load. They often hold control cables onto something, so the control cable has to give a little bit of move, or it goes through a bell crank or something, so that you don't want to squish down the end of the control. I'm talking about aileron controls, elevator controls. You don't want to squish the end into the part, so you want movement between those things. So you put the pin in, you put the nut on. It's barely finger tight, and run the cotter pin through. So there are a lot of times you don't even torque these things. Part subject to rotation. You guys are awful with the phones tonight, man. You are going to lose it. You are going to lose it when you get into Larry's class and have to write essays or give. So that's the tension nut, and the AN 320 is the shear nut. All right, that brings me to plain nuts, but that kind of plain nut. Plain nuts. You guys are plain nuts. Right. Oh, so I already saw that one, but I had a class one time, and the guy said, "Well, that's great. Why don't they make self-locking castellated nuts?" And we all laughed until I looked it up. That's an MS 17825 nighlok castle. When you absolutely positively don't trust the guy putting the cotter pin in, I don't know, but it's a real nut. Why would you do both? I can't answer that question. Double safety. Huh? That's right. So there we go, the nighlok castle. All right, plain nuts. You have the AN. Did I get that right? I think that was the other way around. That's not. 316 is the tension, and the 315 is the shear. So, plain nuts. So plain nuts. Whenever you use a plain nut, what keeps the nut? So I've got this a lot today. So people put a plain nut, and so how are they going to safety it? Well, they drill the head. How does it keep the nut from falling off? Safety. The head. Okay, plain nuts. Must be used with a lock washer. Or pal nut. You don't see that happen a lot, but could be. And 316 is the tension. The 315 is the shear.
No.
I am okay. I knew that didn't look right. That's why I said somebody look that up. I did think it was backwards. Thanks. What? 315, 316. I knew it was wrong. Yes. I know. Yes, there was a disclaimer. I'm not to be held responsible for anything I do or say.
He's a professional.
And I'll just edit this part out, so it's not a problem, so you won't see this anywhere
Edit your
else.
video.
What?
You edit your video.
No, that's the joke. I don't actually. I know. Jeez. See what kind of problems you guys cause me? There we go.
We didn't cause the problem.
You cause these problems.
We didn't cause it.
It was better when I just drew pictures. Okay. 315 is tension, 316 is the shear. All better. Okay, so you got to use some sort of lock nut or pal nut. What's pal nut?
Double nut.
It's like a double nut. Exactly right. So, okay, so a double nut is when you would take like a 315 and you want to lock it, take another 315 and turn it against it. Those two, in theory, don't come apart. But while I'm talking about that, a lot of people install studs that way. You put a nut, jam another, what you call jam nut at that point, jam a nut on there. You're not supposed to do that in aviation because it causes stress at that point. But a pal nut, I should have a picture of a pal nut. There's a pal nut. They're just thinly stamped nuts that it's hard to believe they actually work because if you tighten them too much, they just strip out. They're not reusable. And again, they're just thinly stamped steel. And that is supposed to keep you alive right there.
Where would you find that?
You'd find it in this application right here. So this is, yeah, it's poorly torque striped. Torque stripe is, it's a lacquer paste that indicates if there's been rotation on something. So different colors. They did use yellow here, but decided not to. So this right here is a heim joint, H-E-I-M joint, which has a little ball bearing in it. Now I thought that was my next picture because I started talking.
Is that how you would describe the inside of a heim as ball bearing?
It's got like one big ball bearing, one with a hole drilled in the middle.
Yeah.
Okay, so there's a ball in there that's free to rotate, and you'll notice something interesting that this has a large area washer, an AN 970, and the reason why is because if you used a very small washer and that ball that's in there were to break or come loose, the entire end can go right over the bolt head and fall off. So there's actually an airworthiness directive for Cessna that you had to install these on their planes with these type of joints in the engine controls. So they've got a bolt through here, they've got a regular nut, but it looks like it's one of those locking nuts. But at the same point, they put a PAL nut on the end, and then there's a PAL nut right here. So there's a nut there holding, that's what adjusts it up and down. So you got a nut here, PAL nut here, nut here. This is, I don't think that's supposed to be, yeah, that's safety, that part's safety. There's no safety wire there.
Safety wire.
Research, don't worry about it.
Don't worry about it. You got a safety right there. That's called a witness hole. Can I get a witness? What? A witness hole. And what a witness hole is, this joint right here has threads that go down so far. And if you adjust this thing to where the end of this bolt is somewhere up here, you can put a piece of safety wire through that hole. And if you can put safety wire through that hole, it means this is up too far and doesn't have enough thread engagement inside of here. So whenever you have a hole like that, it means that you should not be able to put safety wire through it, that this rod is sticking down far enough.
So if you put safety wire through it, then it's extra safe.
Yes. All right, so that's PAL nut.
What a pound.
What do I want? I want this
That's
one.
best friend.
PAL nut. PAL, what? So PAL nut is a jam nut.
Oh, okay.
So you have one nut, you tighten this against the other nut, so they fight each other and don't unscrew, in theory.
Just enough where it doesn't strip.
Yes, just tight enough where it doesn't strip. They have a one-time use, and acts as a jam nut. Jam nut. All right, washers. The thing about washers is where you use them. Washers are almost always flat. Yes. No, actually, almost used under a nut or bolt. You almost always put it under the bolt head and under the nuts. You almost always use two. Under a nut bolt to protect the part from being damaged. By the rotation of the nut / bolt. So it's there to protect the part. So make sure you use it. What is the exception to that? Okay, exception is like cylinder-based nuts. I said that already. Steel on steel. All right. I know it as the AN 960 and AN 960L. L for light. Means it's thinner. But that number was changed to NAS 1149. That is the standard washer.
Yeah, but then don't you have to put a letter and then...
Yep, then it gets all crazy. Standard washer. And that's all I'm going to say about that. All right, standard washer, standard thickness, heavy CAD plated flat washer, or the half thickness, light CAD plated steel washer. And how do you know the difference if you have them in your hand? Well, if you have one of each, you'll know. And once you get used to them, you'll know. And there's that one, and the AN 970, which is what I said was on the other end of that ball joint. It's just a large area washer. If you're an automotive, you'd call it a fender washer. Don't know. Standard washer, and then we have the AN 970 large area washer. And that brings me to lock washers. Lock washers. All right, so what kind of lock washers we have? Yay, okay. We have, I sold this from www.laserarrow.com. Thank you, laserarrow.com, for your contribution to this class. All right, this is a split lock washer. You can reuse these so long as it's split and it didn't get sprung. So it's kind of like a piece of a spring. And what happens, thought I had a diagram. What did I do? Let me see what I got here.
It's still on the website.
It's all on the website. Oh, I thought I had a decent depiction of how they worked. I do not. I do. Yeah, I got a lot of stuff to do. Well, all right. So you can reuse these as long as they're still split. So what happens, and it seems kind of odd, is you have a washer down below and a nut on top, and as you turn the nut, it is going to, as it starts to back out, this will dig into the nut, and this is going to dig into the washer, and you think, well, what just keeps the flat washer from coming with everything? Don't know what to tell you. All right, reusable. Not reusable. These are not reusable. So this is the small internal, I call them star locks. So internal tooth star lock, not reusable. And external tooth star lock, not reusable. So lock washers. We have the lock washer. Lock washer goes between the washer and the what? Nut. Washer and nut. Not the bolt head. Not between the expensive aluminum part and the flat washer. So it's washer, lock washer, nut. What did I say? Why did I activate your Google? I don't know. All right. Was it? Okay, the split lock can be reused. Can be reused. Reused. If they are not flat when removed. And then the star lock. Not reusable. Not reusable. Yeah.
What if you have left-hand threads?
That's pretty rare, but they're marked in some way. I said that the other day.
So you can't use that split washer then, right?
Oh, yeah, you actually, well, the star, yeah, you still can. That's a good question. All right, let's see. But if it's left-hand thread, it's going to be some special application. It's probably, the rotation will tighten it, and it's usually cotter pinned or, it's, yeah. If it's left-hand thread, it's because it is subject to rotation, so it's most likely has castellated type nut or some other sort of locking device.
The only time I've seen left-hand thread is on lug nuts.
What's that?
On a box truck.
On lug nuts.
Yeah, so I was thinking lug nut, but that's on a car, not an airplane.
Yeah.
All right, so we got lock washers. Talk about screws. Maybe I can make this kind of quick. Screws, oh man, it can get kind of crazy. Philister head, washer head, truss head, pan head, countersunk. Of course, you can't see that because it's, what's that?
He said if I was a screw, I'd be a pan.
Good, glad about that. So you understand the difference between countersunk, I know, and other type. For the most part, screws are not structural. This is the exception. Usually your washer head is a structural type screw, but the other ones are not. Let me see what I have to say about that. Oh, you're supposed, well, this isn't going to work because you can't really see what's going on over here, but because I'm covering it, sorry about that, but you're supposed to match this to that so that you guys can see it here in the class. So what is number 1? What kind of head is that? A what? Let's see, does it do line by line? It does it all at once. Sorry. All right. So Philister, washer head, I know, pan head, truss head, countersunk. All right. Not structural, definitely not structural, possibly, and yes. Oh, I just threw this up here because there's such a thing called reed and prints, and it looks exactly like it. So a Phillips screwdriver has about 30-degree flukes and a blunt end, while the reed and prints has 45-degree flukes and a sharper, pointier end. This makes a better weapon. The Phillips screw has beveled walls between the slots. The reed and prints straight pointed walls. In addition, the Phillips screw slot is not as deep as a reed and prints. Guess what I'm going to call it? Phillips.
Can I ask James for screwdriver?
The proper terminology would be slotted, Torx, Torx set, and tri-wing. Oh, you're not familiar with Torx? Oh yeah, I was gonna say, wait, you work for Chevy, you got to know Torx. I think they were the first ones in the automotive industry to start using them, actually. Oh, they've been out there forever.
Germans.
It first works for their head bolts.
Is it still considered a torque set if it has a little hole screw?
Oh, the little, yeah, I don't know.
That's it.
I don't know.
Tampered. Yeah, tampered torque.
Again, your 5 common types: slotted, standard, slotted / standard, Phillips, Allen, Torx, Robertson square. Oops. There, now bring it over here. I gotta fix everything. All right. Okay, when we talk about, let me go back. I know. Okay, so these type of screws, 1, 2, 3, and 4, these are machine screws. Right? They have machine thread, which is going to work with a standard nut of the right size. And screws come in like number 4, 6, 8, and 10. 10 is also 3/16. All right, but these are not machine screws. These are what I would have called in automotive a sheet metal screw. In aviation, they're called a PK screw, which stands for Parker Kalon. I guess they're the ones that invented it. Huh? Yeah, PK. That's right. I've been waiting for this for a year and a half now. It's a PK screw. All right. These are not machine screws, which means you do not try and force it into machine threads. Not that you guys have, but out in the field, I see this nonstop and it drives me crazy. So when you pull inspection panels off, like a Cessna or any type of airplane, actually, some of them are the PK style that go into what's called a Tinnerman nut, and some of them are threaded, which go into a nut plate. And I see them get mixed up constantly. People force these into regular nuts and back and forth. And that's what we can talk about tomorrow, since I see you're ready to go. So don't go away mad. Go